everyone. Hope you're doing well. Just want to do a video on homework number 88, the homework that went along with the average rate of change. Please make sure that you post this into Google Classroom so you get credit for it. Okay, so the first one is average rate of change from x equals -1 to x equals 3. So this means this is your x1 and this is your x2. So the formula is f of x2 minus f of x1 over x2 minus x1. Remember, you do have to memorize this because they don't give that to you on the final, or the Regents. So f of 3, because that's x2, minus f of -1, that's x1, over 3 minus -1. F of 3, well, notice there's no graph, there's no table, so there's no place for you to get those values. So this is where you had to do that extra work, where either you had to plug it in and show the work algebraically, or you want to get the table from the calculator. Either or, you need one of them to prove where this is coming from. So f of 3 is 12, and f of -1 is 4. So 12 minus 4 over 3 minus -1, which is 4. That's 8 over 4, which is 2. So the answer number 1 is 2. Okay, the next one. The function h of x is given in the table below. What's the average rate of change over the interval 2 to 6? So that is the same thing as this. Okay, that's x1 and that's x2. So we did a question like that yesterday. Notice this is h of x. So either you want to put a key and you want to tell me f of x equals h of x so that you can use this formula, which I think I prefer that over this, or you can switch it to h of x2 minus h of x1. I think I'd rather you do it this way because this is the standard formula and use the key. Okay, so second one is 6, first one is 2, and f of 6 is 3, f of 2 is 9, and then after you do your math, remember, make sure that you simplify as much as possible. You will get -3/2. Okay, so now we're going to do an average rate of change when we're looking at a table, a graph, excuse me. So we want to go average rate of change between -6 and 4, and then -2 and 2. All right, so we have our formula for both of them. x2 is 4, x1 is -6, and it's also 4 minus -6. Remember I said yesterday, these numbers will match here, okay? They should be in the same order. So f of 4, so you're going to come to this graph. Remember, 4 is your x. 1, 2, 3, 4, and then go up to where the graph is. And what value is that on the y? 1, 2, 3. That's a value of 3. That's where the 3 came from. And -6, 1, 2, 3, 4, 5, 6, it should be 1. So that's where that value came from. 3 minus 1 is 2. 4 plus 6 is 10. 1/5. Next one, x is -2. 1, 2, 3. That's going to be, sorry, let's try that again. So f of x2, so 2 goes here, -2 goes here, okay? And then it's 2 minus -2. F of 2 is -1, that's where that comes from. F of -2 was your -3, that's where that is from, okay? So -1 minus -3 is really -1 plus 3. 3 minus 1 is 2. And then 2 minus -2 is really 2 plus 2. 2 plus 2 is 4, which is 1/2. So 1/5 and 1/2 are your answers for the front, and you got these values right from your graph. Okay, on the back, we have a word problem. 1997, a town of 50,000 people started growing, so 50,000, by 1,000 people each year. Complete the table showing the town's population every 5 years or 15-year period. So you got to be careful because if you don't look carefully, you could think these go up by ones, but they don't. They go up by 5. So every year is 1,000, which means every 5 years would be 5,000. So notice these all increase by 5,000. Average rate of change over the 15-year period. So they want you to start with x of 1 is 1997 and x of 2 is 2012. You fill in your information, you get the numbers from the chart, and it looks like it's 15,000 over 15, which is 1,000, which you can also actually get the easier way we did yesterday. You do every single change in y over change in x. Remember, this is x, this is y. You will see it's 5,000 over 5, which is 1,000. Each time it comes out to be 1,000. Okay, so I said, if you do that method and all of them are the same, then yes, it is indeed linear. Okay, that +1 doesn't work this time because these go up by 5. So 5,000 over 5, a change of 5,000 over 5 will get you 1,000. Each time is 1,000. But you also know from here, this is the rate of change. So this is 1,000. Yes, it's linear, okay, because this is all constant. This is what you start with. So your formula is P of x equals 1,000 x plus 50,000. So 1,000 is your slope, 50,000 is your beginning. So this is your beginning. Remember, rate of change is fancy for slope. Number 5. The tables below show the amount of money in different bank customers' account. The first day, 5 months, constant. Okay. So if they don't say anything, they don't tell you they're looking for linear, quadratic, they don't tell you what they're looking for. They just say constant. That does mean they're looking for linear. So you can assume that they are looking for linear. So I said yesterday that if it goes up by 1, you can just do this quick little, trick method. So all of these here on the left go up by 1. And then take the differences of the y's. And you'll see that this last one is the only one where it goes constant on the first try. First try was your linear. Okay, so constant means go up by the same amount. So just really by looking at it, you could tell this is the only one that keeps going up by the same amount. And then the last 2. Okay, again, this is your kind of like a shortcut way. These will go up by 1, so you can do that shortcut. Here it took you to the 3rd try to get it to be the same. So 3 is cubic, and you want to say it's cubic because the rate of change is constant on the 3rd try, or 3rd common difference, whichever way you like better. Here it goes up by 1. Here on the 2nd try, it was the rate of change was constant, so you know it's quadratic. So the rate of change is constant on the 2nd try, or 2nd common difference. Okay, remember you can also, I'll just show you one of these. I'll show you the quadratic one. So you can also do this on the calculator. That's stat 1. Clear, press down, go up to L1, press clear, and you put these numbers in the calculator. Press enter. After each time you put in a number. Okay, you can actually also see that symmetric pattern, so you know it's quadratic. All right, make sure these are right. -2, -1, -6, -9, -9. Okay, good. So you want to make sure your stat plot is on. So the shortcut was y equals, go up to 1, press enter. And you want to press zoom 9. And I think you can see, I hope you can see that looks like a curve, looks like a quadratic. So that's also how you can check these a different way. Okay, hopefully this helps, and have a great day.